אז ברשותכם, או גם לא ברשותכם, אני אעבור לאנגלית, כי זה פשוט יותר נוח. So, hello everyone, and welcome to my talk, Take Control, Write the Plugin. My name is Noam. I work for JFrog. I've been there from day one. I'm developing on the JVM for more or less 10 years now. My work has been mainly in Artifactory and also in the ecosystem with all the build tool and build server integrations. Today we're going to talk about Jenkins plugins. You can see in the agenda that first we're going to start about the rationale of plugins in Jenkins, why Jenkins needs plugins, and what it means to it. We're going to see what actually makes a plugin, maybe a 10,000-foot overview, if you will. Then we're going to see how to develop one. We'll see what we need in our environment, which is pretty simple, and then some code and a little demo. All fairly nice. So, what's the meaning of plugins? As we all know, Jenkins has a ton of plugins, and it's a really important feature of Jenkins. So, maybe the number is a little bit exaggerated, but it's getting there, and it's getting there quick. And the choice is amazing, because you have professional-sounding things like cluster management, and you have silly time-wasting plugins which amuse our simple little minds. And there really is a plugin for anything, apart from maybe making coffee and a couple of other issues. So why would you need to write another one? Why would you come to such a talk? So from the way I see it, plugins basically originate in needs. We need Jenkins to understand the language we write in. We need Jenkins to talk to our tools, whether it's SCM or build tools. We need Jenkins to prepare the environment, talk to the type of storage we use, parse our test results and all that. And of course, a great community like Jenkins needs contributors like you or like me to share our work, basically. So maybe your build type is pretty simple, and maybe the plugins which already exist out there are enough for you. But the thing is, not every build is the same. Working in JFrog, we see some pretty exotic builds. Some not so justified, and those are easy to solve. You just change the build cycle and get rid of those who are responsible for it. When it is justified, you have to make changes and you have to adapt. So that could be either infrastructure or tools, and namely Jenkins plugins, which can help a lot in this case. So let's look at what actually makes a plugin. One thing before we start, though, is know your borders, because you shouldn't write a plugin for anything. There are some things which Jenkins shouldn't do. Things like store your binaries, for example. So it should be a complement, okay? It shouldn't be a replacement for the tools you have. It should prepare your environment for you. It should talk to your tools so you don't need to talk to them. It should learn to monitor them so you don't have to monitor and worry about it. And obviously automate everything. And let's not forget Chuck Norris, too. And you can extend a whole lot of things. This is really just the tip of the iceberg. Okay, so you can extend the UI. You can have it poll for your SCM tool. You can have it check out your directories or files. You can run your own build processes, whether it's on the console or maybe a specific build tool, manage slaves, and just generally any sort of tooling. But it's really, there's so much more. I can't even start to explain the number of plugins which exist. And you can even go meta. So if the given extension points aren't enough to you, you can always create your own. A plugin is pretty simple. I see cross case here, so if I make any mistakes, don't stop me. Okay? And it normally revolves around the extension or the hooks. So that is basically the plugin. And you can attach UI to it. It's not a must. You can have plugins without UI. And around it, you can write all your models and your business logic and all that boring stuff. And this is how it's built generally. So you have your UI, which are normally jelly files, but it can also be groovy. If I'm not mistaken, it's just a facade over the jelly models. Now, jelly is sort of like JSP if you've ever used it. So it's a kind of mix of HTML, XML, and code, which is eventually compiled and is translated to the final HTML, which you see in the UI. Now, your jelly files, which are XML files, are bound by naming convention to your actual extensions. So if you have an extension with a certain name, you will have the same name in a jelly file, which will define the UI which can control it, whether it's the general configuration or a per runner configuration. Your extensions can be written in either Java or Groovy or Ruby. I'm sure someone will come up with something else pretty soon. It's kind of asking for it. And you can either use extension annotations or just extend your superclasses to get the functionality that you want. Like I said, you can also optionally expose your plugin settings or any functionality using the UI. And you can also optionally persist this configuration to the disk. That goes for both the global configuration, which exists as a singleton entity within Jenkins, and your per runner configuration. So plugins are installed in a pretty simple way. You can either install it through the file system or manually through the UI. And if the plugin which you need exists within the update center, you can just do it from the update center in Jenkins, which is normally the preferred way. So once a plugin is inside Jenkins, what does it actually do? Where does it exist? So the normal area of it will be in your build cycle. Apart from that, you have some independent ones like the UI extensions or maybe scheduled tasks like backups. But as you can see, the majority is probably in the build cycle. I'm just guessing that. I don't really know. And it's a pretty simple flow. So it starts with preparing the environment, with preparing the SCM, whether it's polling or checking out your code. Then you can perform actions before your build actually occurs. You can also extend the builders to create your own builder processes. Then you create post-build actions to do the work, perhaps to clean up your environment afterwards. And lastly, you have the publishers. So the publishers, they act once the build is finished, but they can still affect the results of the build. So the type of plugin which I'll demonstrate today is actually a notifier. So a notifier is a subtype of a publisher. The only thing is it runs at the complete end of the build, so the result is determined already and you cannot affect it anymore. So how does the environment look like when we develop? It's pretty simple, actually. I'll be using only mainly two tools, apart from the obvious ones like a browser and a terminal. So I'll use IntelliJ IDEA, which is excellent, and Gradle, because it's the best build tool around. Normally, you can also use Maven, and I think that's also the typical setup. But the Gradle plugin is pretty new, and we should promote it because it's, I think it's going to be big. So also, the structure of the project is quite simple. You can see it looks like a pretty fairly standard Java project. You have your project descriptor, and you have your Java and resources and any static resources which you might want to serve. So we'll look into those. Your build.gradle file, well, it defines your project ID. If you know it from Maven as gavc, maybe you know it from Ivy as omrak. It defines your dependencies. If you need other plugins to do your work, if you need perhaps other libraries to achieve whatever you want to achieve. You can also define your own Gradle plugins within the build.gradle. So we're going to see today which I'm using the Gradle JPI plugin, which is like the Maven HPI. And also you can customize the process. So Gradle is very versatile. You can do almost everything you want within it. It's pretty freestyle. In the main.java, sorry, main/Java, that is pretty obvious. You have all your extension classes, you have your domain classes, any other logic which you might need. Resources hold the UI files, which is either normally Jelly or Groovy, and it can be either extensions of the plugins and the existing UI, or it can be independent UI within itself. You can also add property files for internationalization if you want to translate any of your components, as Koska showed us this morning. You can put it there too. And in the end, when everything's ready, we simply run two goals, Gradle clean JPI. This will prepare our plugin archive, which we eventually deploy or distribute. Okay. And another nice feature of the Jenkins dev environment, which is running Jenkins on the fly. Now, this is really cool because you basically take your code, take your build tool, and run Jenkins pre-deployed with your plugin. And it's excellent because the Jenkins, which is distributed for the development environment, has a couple of modifications over the standard ones, which we'll see soon. And it's one command, and you have a Jenkins up in the air. So let's do a demo. We'll build a very simple plugin. I'm calling it the motivation plugin. What it does, it detects failing builds and displays messages accordingly. Obviously, motivational. Okay. So we'll start by reviewing the UI. I'll hop now and again in between the UI and the code. Okay. And we'll see how a basic plugin looks like. we all know Jenkins. Let's go into the most basic part of the, sorry, I'll start the server. You can see it's one command. It's in the bottom, might be a bit hard to see. Great, server is up. Right, so we all know the plugin installation. You go to the manage plugins, and if I go to the install plugins, you can see that my motivation plugin already comes pre-installed. Now, the most basic part of the UI is this small description here of our plugin. And this is the main Jelly index file, which that I guess is all its purpose. You can put in there HTML, and whenever a description of a plugin needs to be displayed, it'll be there. So if we go to the project and look at the tree, we go into the resources and to the index.jelly file, and it's pretty simple. We have our explanation, some standard HTML tags can be put in there, nothing fancy really. Now let's look at the global configuration of our plugin. So as we said before, every plugin can have its own configuration, and it can have a global configuration which applies to all of Jenkins, and a per runner configuration, which is per configuration of a runner. Now, the global configuration acts as a singleton. That is, you define one class which holds the data, you define one Jelly file which provides it with a UI, and that's all it needs basically, and it runs once. So if we go into the general configuration once again of Jenkins, we can see in the bottom, we'll see in the bottom, I've got my motivation plugin configuration. I've defined a nice motivating message here. You can obviously modify it. It also contains a validator, which I think works. Why no insult? But it was still saved for some reason. Never mind. Let's reapply the message. And this is also quite simple, also within a Jelly file, but now combined with Java to describe the logic of persistence. So if we go to the global Jelly file, this exists within the resources. Now notice that the global Jelly file exists within a motivation notifier package. Now, if you remember, we spoke about how it's bound by convention, naming convention. And you can see that my plugin is named motivation notifier, so is the package. And within the package, you have the global and the config Jelly files. So let's look at the global. So meet Jelly. Okay, you can see it's, like I said, very much like JSP. You've got your standard library tags. You can build forms. You have core operations like flow structures and things like that. And we can see that we have a section where we define the title, motivation plugin. We define a text box wrapped by a title and a specification of the field which will eventually end up in the persistence. So this doesn't have to match the field within the class that's bound to the Jelly file, because you have control over the JSON, as we'll see soon. So how does it look like in Java? If I go into my motivation notifier plugin, I've defined an extension called descriptor impl. And you can see it extends from build step descriptor and type publisher, which as we explained earlier, is our super type, because we're a type publisher. And I've got the field to represent the motivational message. So in the end, this class is what will be persisted. So you can see I've got a number of fairly basic operations. So the first operation we can see here is the motivation message validator. Now this is also based on convention. You can see the method starts with do check and then ends with the name of the field which I want to check, the default motivation message. And it's a simple check. I check if it's on blank. If it's blank, I present an error. If not, it's okay. Up next is the configure. So this is the code which actually persists the data you get. So if you can see the arguments are being passed in, you can see the stapler request. Now, stapler is a library which actually makes a connection between the Jelly files and the Java files. Now, you also have another parameter, which is the form itself, which is a JSON object. So all the data from the form comes in JSON text, and it's very easy to manipulate later. So you can see I can extract from the form the default motivating message, which complies to the name of the field I've defined. And I simply set it to the field in the Java class. Now it's important to note that you have to save your configuration here when it involves the global plugin. Otherwise, your data won't be persisted because it's basically a serialization of XMLs. I also call my configuration of the super type in case there's any functionality which I do not want to miss. Another couple of methods here that we have are getDisplayName, which in the end ends up in the display of the UI. If I go and see motivation plugin, it goes up in a section. I have a method which is called isApplicable, and what that does, it lets me match the job type which we look at currently, and tells me if the motivation plugin can run at it or not. So I obviously want to run my plugin on any type, so I just return true always. But you normally can check if it extends Maven, extends Gradle, if it applies to such a specific builder. Now we also have a getter here, and you'd wonder why we need a getter on a class that's basically serialized. So the nice thing about Jelly, you don't see it in my demonstration, sadly I didn't put it in, but you can actually access the class you are bound to within the Jelly. So if I want, I could insert here code to perform any sort of manipulation, call methods, call fields, all within this class which I am bound to, which is the nice part, because you can create kind of smart forms if you've seen them around Jenkins. So this is the global configuration. Let's look how you define the configuration on each builder. So we'll go back to the main menu. And you can see I've defined the job here. It's a freestyle job, and it's called always failed. As you can see, it's pretty gloomy, kind of like Gotham City. And if we look at the configuration, we can see the second part, where I basically let you apply the plugin. Either enable it or don't enable it. Pretty simple. It's also a checkbox. And it's also same sort of simple section as we saw in the global. Only this one exists per runner. It's not a singleton anymore. And for this, we have the main class of the motivation notifier. So you can see we're inside the motivation notifier now, but that was the descriptor import. That is the global configuration, which, as you remember, is a singleton. But if I go up, I can see my main class is actually motivation notifier, which extends the notifier type, the way you saw earlier on in the diagram. This too also is persisted to XML, so you can see I have the same compliant field, a Boolean field to choose if to enable or not. It also has the accessor method, because the same way we can access the code. Okay. And the persistence is a bit nicer with the runner configuration, because you can actually bind it to the constructor. So whatever parameters are sent from the form will actually be sent to your constructor, as long as you use this nice annotation data-bound constructor. And you just save it to the fields, and you don't need to call save, you don't need to call anything. It's all saved to disk, obviously in XML format. So then we get to the interesting part, which is perform. And the method perform is actually specific to the notifier. Obviously, with each different type of plugin, you'll have different type of extensions. If you have SCM, you'll get to define the polling times. You get a hook for before build, so you can check out, and so on. So I get the context of my build. I get the build object and the configuration of it, because the build is already run. And I get a build listener, which gives me the context to the instance of the build itself, which is still running. And I get the launcher, which provides me with certain utilities, not currently relevant. So here I can see that I'm inspecting the result. I ask if the result of the build always fails, and the user is selected to enable the motivation messages, I'll print my message. Pretty simple. So I get my descriptor, and as you can see, this method is an accessor towards the global configuration singleton, so I can retrieve the message which the user chose to display. And via the listener, I can get the logger for the build, that's the logo which you see in the UI when you choose console output, or what was it, Melel this morning? It's pretty funny. So I've pumped up the message a bit, so it'll be a bit more noticeable when we run the build. And let's see how it performs. So I'll go to Jenkins. I'll go back to the configuration I'll just show you. So this is a build which will all fail. Okay. I think it's gibberish. Perhaps means something in some Unix utility. But not in this case. This will fail. And I've chosen to enable the motivational messages. So I'll save the project. I'll run it. Failed pretty quickly. We like it quickly. Now you can see the build failed. No, I do not want to inspect. Yes. And nice going, buddy. You broke the build. Nice, eh? Okay, so this more or less sums it up. And once you prepare your plugin, obviously you can do whatever you like. If it's an internal plugin, you can distribute it within your organization using Artifactory or any other leading product in the sphere. And you can also distribute it through the Jenkins Plugin Center for the whole world to use. And if you've created something useful and not something like this, I really encourage you to share it, because someone else might need it too, and be great help. You get contact with people from the community, you get help, you get beta testers. It's all very nice. So this was me. If anyone has any questions. Nothing? All shocked? It was pretty impressive, wasn't it? So, thanks to our sponsors. Links, I've got the demo project in GitHub if anyone's interested to get the example. I've got the plugin guide, the extension types too, and the wiki for the JPI. Start using it. If you're using Gradle, you'll get the presentations later. It's okay, you can have. Yes, sorry. Stapler. So Stapler basically takes the form, serializes it, and when you look at the constructor of the plugin, you can see it's a data-bound constructor. And whatever parameters you defined in your job configuration will eventually reach this constructor. Obviously, you have to maintain the naming conventions so they'll match, but this way. I'm pretty sure you can also customize this matching too. Yes. What it does, it downloads the Jenkins var only one time because it's cached. And the Jenkins var, as you know, is executable. You don't have to deploy it into a application server. You can just execute it. It's got a built-in application server, and it loads it into the class loader. So you've got a Jenkins instance instantly. Let that guy, sorry. Well, templates are still plugins. I'm not too sure about talking about the templates because it's in the pro version, sort of the pro enterprise version of CloudBees, and not my calls, but those are eventually, I'm guessing, plugins, only ones which you can reuse. I'm sure Kosuke can elaborate on that. You wanted to ask something earlier? So yes, you contact the community. I'm not really sure who leads this today, but basically you get an account with credentials to the Git repository, and you get your own repository, and you develop your plugin locally, and then you perform merges into that official Jenkins repository. They run the build, and they upload it to the center, and it gets distributed together on every iteration with all the rest of the plugins. I'm pretty sure they have any published guidelines. I didn't include the link, but they have them. Yeah. So you've got a build listener plugin. Okay, so the guy asked if you can write a plugin which will interact with the build process itself, which is basically, that's sort of the build listener. I'm going to have to check the wiki of the plugin types, but I'm pretty sure it's there. Yeah, it also probably depends on the type of process you're running. Obviously, to tap into a process, it's a personal thing for each tool. Anything else? No? Oh, yeah, sorry. Well, the environment is still not exactly the same. You've got some differences when you develop. Obviously, because it's JRuby and you run in the same JVM, you can also you reutilize all the extensions. So it's practically the same in a different language. The environment is a little different. It's not as developed as the Java and Groovy one yet, but if you do develop in Ruby, give it a shot. Yeah. Cool. Okay.